Alright, so in this video, this is just kind of a review of some of the characteristics of polynomial functions you found in the past. So analyzing graphs might mean that you're finding max and mins, or domain and range, or increasing and decreasing, or x and y intercepts. And we're going to focus on the things that apply a little bit more to the unit that we're learning in calculus. So we're going to look for all the extrema, so all the max and the mins, whether they're absolute or relative. We're going to look for the increasing and decreasing intervals, and we're going to show where the graph is concave up versus concave down. So, maximum and minimum. Here, none of these have endpoints, so if you notice, all of these have arrows on either end. So we are looking for negative infinity to positive infinity for the domain, so the endpoints are not going to be something that we're going to consider for a max and a min, which means that for some of these problems, they may not have an absolute max or an absolute min. It might just be relative. So the first step for this, to make sure that you can find these by, we're just practicing on the calculator, something that you've done in the past. So I'm going to go ahead and graph this. And having a window from -10 to 10 is going to work for most of these. You could also make your window match up with the graph itself and go from -8 to 8. That would work as well. So we have a relative maximum right here, so I'm going to say I'm doing second trace. That's how you get to this menu. And maximum is number 4. So I need to scroll with the cursor and go to the left side of this maximum. So left bound means I just have to go to the left side of it. Right bound means I need to scroll to the right side. And to scroll back and forth, I'm just hitting these left and right arrows. So scroll to the right side. It always gives you a guess, and the guess is always dumb. And so here our maximum is at 0, -2, and I know this does not look like 0, it says E, and that's because this is in scientific notation. Let me write this down. So here's our little, you do not have to write this down, but this is our little mini lesson remembering science classes before. So anytime you see that on the calculator, it really means -1.153 times 10 to the -6th. And if you guys remember how scientific notation works, this is taking your decimal and moving it 6 places to the left. So 1, 2, 3, 4, 5, 6. That's terrible. So 1, 2, 3, 4, 5, 1, 5, 3. So that is the actual decimal that your calculator was talking about, and that is basically 0. So that the x-coordinate there was 0, the y-coordinate was -2. And so I'm going to say here that my relative, or my local max, is at the point 0, -2. Of course, we know that the relative max is located at 0 with a value of -2. We're going to be consistent with how we're describing these things. So looking for the relative minimum. So my relative minimum is down here. So right now I'm on the left side of it. I'm going to scroll over until I'm on the right side of it. And my relative minimum is at the point 1.333, -3.185. All right, next we want to find the increasing and the decreasing intervals. So increasing intervals are x values that make the y value go up. So these are some x values that make the y value go up. And I'm going to go ahead and sketch the graph off to the side so we can label the picture. So negative infinity is the x value down here because that's a left arrow. So the x value is from here all the way up to this maximum, and the x value there was 0. These are all x values that make the graph increase. This little section of the graph is decreasing, and the x values that make that happen are any x value between 0 and 1.333. So that's where the graph is decreasing. And then after that x value of 1.333, the graph starts increasing again, and it increases all the way to infinity. So for my increasing interval, I'm going to say I've got negative infinity to 0, and 1.333 to infinity. The decreasing interval would be from 0 to 1.333. So there's my increasing and decreasing intervals. And then the last thing that we want to find is where the graph is concave up and concave down. So concave up means that you have a U shape that's turned up. So like this would be concave up. Concave down is where you have a U shape that's going down. So we have to look at what makes the U shape. So if you look halfway between where these U shapes, like the vertex kind of, where these points like turn around, halfway between those is where it switches. So usually you can kind of tell where the switch is made. So I'm going to say this pink part is the concave up part. And the yellow part is concave down. So I'm going to say concave down is in yellow, concave up is in pink. So I think that the mins and the maxes and the increasing and decreasing are pretty doable, hopefully for you guys, but maybe let's look at another one to practice the concave up and down, because you might not have looked at that before. So I skipped number 2 because I think number 2 is pretty simple. If we look at number 3, I can see that this part here is concave up, and then somewhere in here it switches to being concave down. So I'm going to look about halfway, and we're not being super exact here. We're going to be exact when we start doing it in calculus, but right now we just want to get the general idea of how it works. So this part right here is going to be concave up, so that's the U shape going up, and then it switches to concave down. So we've got that happening. All right, this one goes back and forth. So if you look, we've got concave down, and then it's going to switch to concave up. There's a U that's going the other way. And then it's going to switch back to concave down. And then it's going to switch back to concave up. And that's how this graph finishes.